Hello again. I'm going to be doing problems. I believe is 61 all the way to 70. So be patient with me. We're going to get there. We're going to get there. Okay, they're giving you a mathematical expression. They want you to simplify. This is easy, guys. 2 to the third power is the same thing as 2 times 2 times 2, which is 8 right here. 3 to the second power is 3 times 3, which is 9. It's right here. Be careful with this one because it has a negative exponent. So 3 to the negative 2 power. Every time you see an exponent with a negative sign, you bring it down. So this is the same thing as 1 over 3 to the second. This was negative on the top. It's going to become positive at the bottom. So 1 over 3 to the second is 1 over 9, which is right here. So we're done with this. We're done with this. We're done with this. And this one is almost very similar, which is 2 to the negative 3 power. 2 to the negative power is the same thing as 1 over 2 to the positive 3 power, or 2 cubed. So this is going to be 1 over 8. And ladies and gentlemen, it's right here. So I'm done with this one. And this is kind of like you can do it mentally, because when you have a power over a power, you just multiply the exponent. So 2 to the third power to the second power, 3 times 2 is 6. So it's 2 to the 6th power. So we're done with this. 2 to the third to the second, you just multiply the exponents. And then I'm going to be moving to this series of problems right here. And they're asking you to factorize. Let me see if I can get a clean piece of paper. Let me do each one of them separately. This one is a difference of square. How do I know it's a difference of square? Because there's a subtraction sign that is a difference. I'm making it a little bit bigger. That is a difference. And this is a perfect square because x to the second power is x squared and 2 to the second power is 4. So when we have something like x squared minus 4, it's going to be x. I write x here. One is going to be plus, the other one is going to be minus. This is 2 and this is 2. That's the way that we do it. We learn in class that if you don't believe me, x times x is x squared. X times negative 2 is negative 2x. Positive 2 times x is positive 2x. And positive 2 times negative 2 is negative 4. As you can see, the negative 2x is going to cancel the 2x, cancel, and you're left with x squared minus 4. Another example would be x squared minus 9. It would be x plus 3, x minus 3. X squared minus 16. It would be x plus 4. X plus 4, x minus 4, and so on. Now, this one, number 60, x, let me jump 68. This one is nothing. You cannot factorize x squared plus 4. You see this one here? Just ignore it. And the answer is going to be, cannot be factorized. So I did this one. I'm sorry for jumping a little bit, which is a different squares. This one cannot be factorized because this is a perfect square. This is the perfect square, but this is not a difference. It is an addition. So it cannot be factorized. Now let me work with problem number 67, which is x squared plus 6x plus 9. Look at this. 9 is the same thing as 3 squared. And this is x to the second power. This is the perfect square. This is the perfect square. Then I say two numbers that multiply will give me 9. And that added will give me 6. Multiply will give me 9, 3 times 3, but when I add them, they give you 6. This is a perfect square. Parenthesis, parenthesis, x, x, plus, plus, and this is a 3, and this is a 3. It's the same thing as x plus 3 to the second power. This is the perfect square. Let me do this again. I did not notice that the paper was not there. X squared plus 6x plus 9. Two numbers that multiply will give you 9, but added will give you a 6. So those two numbers are 3 and 3. This is a perfect a polynomial, perfect square, because this number multiplied by itself gives you 9 and added will give you a 6. 3 times 3 is 9. 3 plus 3 is 6. So the answer is x plus 3, x plus 3. What about if you had something like this? X squared minus 6x plus 9. Let me break it. Let me remove this parenthesis. There is no need for this parenthesis. X squared minus 6x plus 9. Here, two numbers that multiply will give you 9, but added will give you a negative 6. No problem. Negative 3 multiplied by negative 3 is positive 9. And negative 3 plus negative 3 is negative 6. So this is a perfect quadratic equation. So what is the answer? Parenthesis, parenthesis, x, x. But instead of being a plus like before, you see, instead of being a plus, it is a minus. So this is going to be minus, minus 3, 3. You see, so these two problems, look at here, follow me. These two problems are very similar. The only difference is that this is plus and this is minus. So the answer for 67 is this one right here, x plus 3, x plus 3. The answer for 69 is x minus 3, x minus 3. And the answer for 66 is x plus 2, x minus 2. And now this one cannot be factorized, and the only one that I have left is x squared plus 5x plus 6. This is not perfect. Not perfect because this is not a perfect square. This is not a 9. This is not a 4. This is not a 16. This is not a 25. This is just a 6. So you say, what two numbers multiply will give you 6 and added will give you 5? Which two numbers multiply will give you this one, but when you add them, will give you the middle term? Hello, is 2 and 3. So I put here parenthesis, parenthesis, x, x. This is a plus. It's going to be plus, plus. And then I have here 2 and 3. That's it. That's it. If you don't believe me, for those of you that are non-believers, x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. How much is 3x plus 2x? 5x plus 6 plus x squared. This is exactly what you had right here. Bye. See you in the next video.